What is a matrix? And the plural of matrix is matrices. So a matrix is just an array of numbers. So if I say the numbers 5, 6, and then I do 2 and 4, and if I put like brackets around it, this is what a matrix looks like. It is an array of numbers. So it has a certain amount of rows and a certain amount of columns. So in this case, we have 2 rows. So 2 rows. So that's row 1, row 2, and then we have 2 columns, 1 and 2. So 2 columns. So the way we write this is we call this a 2 by 2 matrix. A 2 by 2 matrix. So the rows come first and then the columns come second. So for example, if I had 4, 3, 6, 1, 0, 1, well, this would be a 2 by 3 matrix, right? Because we have 2 rows, 4, 3, 6 is the first row, 1, 0, 1 is the second row, and then 3 columns. 4, 1 is the first column, 3, 0 is the second column, 6, 1 is the third column. So rows first and then columns. Now, what we want to do with matrices, we want to add, subtract, multiply, and divide, right? Because that's the basic operation. So how do you add matrices? So you can only add matrices if both of them have the same dimensions. So these are the dimensions, 2 and 2 by 2 are the dimensions of the matrix. So you can only add if dimensions, I'm gonna write dim, are same. So you can't add a 2 by 2 and a 3 by and a 2 by 3 matrix, or you can't add a 3 by 4 and a 4 by 3 matrix. But you can add a 2 by 2 and a 2 by 2 matrix. So if I want to add, let's say, 1, 2, 3, and 5, and to that I want to add 6, 8, 9, and 1, well, I would just add each element in that row, the first row in the first column in this matrix is 1, and the element in the first row in the first column of this matrix is 6. So I would add 1 and 6 and I would get 7. It's very intuitive. It's what you would expect it to be. Then you would add 2 and 8 because they're in the same positions. They're in the first row and the second column. So 2 plus 8 is 10. 3 plus 9 is the second row and first column. So 3 plus 9 is 12. And then 5 and 1. That would be 6. And then the same way you subtract, you would do what if it was subtract instead of add, you would do 1 minus 6. That would be the first entry, and then 2 minus 8 would be this entry right here, 3 minus 9 would be this entry right here, and then 5 minus 1 would be that entry right there. So you can only add if they have the same dimensions. Now let's talk about multiplying matrices, because this is way more interesting. So how do you multiply, or can you even multiply matrices? So you can only multiply matrices, and this is a trick that you should remember. So let's say I give you a matrix that's 3 by 4, and then you multiply that by a 2 by 2 matrix, let's say. You're doing that. I'm going to tell you right now, this is not possible. Okay? And you will see why when we actually start multiplying. It becomes intuitive once you try to do it many times. So 3 by 4 and 2 by 2 won't work. But what will work is, let's say, a 3 by 4 and a 4 by 3 matrix. This will work. And I'll explain what the rule is. 2 by 2 and 2 by 1, this will work. So this is correct, this is correct. But if I tell you 2 by 2 and then I tell you a 1 by 2 matrix, this is again not possible. So how do I know what's possible and what's not possible? So this is the way to do it. So in matrices, you have to remember, matrices are not like normal multiplication. So in normal multiplication, if I told you 6 times 5, that's 30, right? Then I told you 5 times 6, that's also equal to 30. So 6 times 5 is equal to 5 times 6. This is normal multiplication with numbers. But in a matrix, let's say you have a matrix A and you have a matrix B, so you're multiplying them. This is not equal to the matrix B multiplied by the matrix A. So this is very, very important. You have to remember this, because this is something that's very different in matrices compared to what we're used to. So AB is not equal to BA, and you will see why now, because so let's look at the matrices I just gave you. I gave you 3 by 4 and I gave you 2 by 2. So it will only work if the columns in the first matrix match with the rows in the second matrix. So you can see 4 and 2 are not equal to each other, so this won't work. But over here, the columns in the first matrix is 4 and the rows in the second matrix is 4. So they are the same, so that will work. Here, the columns in the first matrix is 2 and the rows in the second matrix is also 2. So this will work. Here, the columns in the first matrix are 2, but then the rows in the second matrix are 1. So this will not work. So, in general, let's say you have A by B, okay? This is the dimension of the first matrix. And you're multiplying it by a matrix that has dimensions C and D. Okay, this is only possible, and there's actually one more thing you can get out of this. This is only possible if B is equal to C. So that's the only thing that's possible. And what you actually end up getting, the result matrix, so the result matrix is actually going to be A by D. That's going to be the dimensions of the resulting matrix. So let's do an example and it will make way more sense. So let's do a 2 by 3 and a 3 by 2 matrix. So let's say I gave you 3, 1, 0, 4, 2, 8. Okay, so I'm going to write over here on the side, this is a 2 by 3 matrix. And then I'm going to give you a 3 by 2 matrix. I'm going to give you, let's say, 4, 0, 0, 1, 1, 2, 2. I'm giving you a 3 by 2 matrix. Okay, so that can't happen. So I'm going to give you 4, 0, I'll give you 0, 1, and I'll give you 3, 6. So this is a 2 by 3 matrix. Oh, this is a 3 by 2 matrix. So this is 3 by 2 because 3 rows and 2 columns. So so this should work, and we should end up getting a 2 by 2 matrix. So let's see how this would work. So I'm going to do it right here. So I would do 3, 1, 0, 4, 2, 8. I'm going to put that there, and I'm going to multiply it with 4, 0, 0, 1, and 3, 6. So how would you do this? And how would I end up getting a 2 by 2 matrix? So what you do is, you take the first row, the entry of the first row, first column, you multiply it by the entry of the first row, first column in the second matrix. So you multiply this, so you do 3 times 4. And then to that, you add the first row, second column entry, multiplied by the second row, first column entry. So you multiply with that. So 1 times 0. So plus 1 times 0 plus, and then you do the first row, third column, multiply by the third row, first column. So you multiply that by 3. So plus 0 times 3. And that's going to be your top left entry. Now the top right entry is going to be these numbers multiplied by the second column. So I would do 3 times 0, so that's 0, plus, I don't have enough space, so I'll just write the answer. So 3 times 0 plus 1 times 1, so plus 1, plus 0 times 6, which is 0. Now we go to the entry right here. So this is going to be the second row, first column entry in the resulting matrix. So I would do the second row times the first column. So I would have 4 times 4, which is 16, plus I would have 2 times 0, which is 0, plus I would have 8 times 3, which is 24. And then so this is the first entry, this is the second entry, this is the third entry. I'm just going to put comma so that we know there's like a difference. And then the last entry is going to be the second row times the second column. So I would have 4 times 0 is 0, plus 2 times 1 is 2, plus 8 times 6 is 48. So plus 48. And now we can write the answer out. So now our resulting matrix is going to be, so 3 times 4 is 12, plus 0 is just 12. So that's 12. And then we have 0 plus 1 plus 0 is just 1. 16 plus 24 is just 40. And then 0 plus 2 plus 48 is just 50. And that's it. Look, we ended up getting a 2 by 2 matrix. And I told you that's what's going to happen, right? We have a 2 by 3 matrix. So the 3's and the 3's match. So we can multiply. And then we end up getting a 2 by 2 matrix because that's A and that's D. So that's how you multiply matrices. Let's do another example. Let's do it way quicker, okay? So actually we're going to do this. We're going to show AB is not equal to BA. Let's show this. So I'm going to give you A is equal to 2, 3, 4, 5. And I'm going to give you B is equal to 1, 0, 3, 4. Okay, these are just random numbers I made up. Okay, so let's multiply. So let's do AB. So AB is going to be, so you're going to multiply 2, 3, 4, and 5 with 1, 0, 3, and 4. So what are you going to get? So once again, first row multiplied by the first column. So 2 times 1 is 2, plus 3 times 3 is 9. So 2 plus 9 is 11, so that's 11. And then the first row times the second column. So you'd have 2 times 0 is 0, plus 3 times 4 is 12. So 0 plus 12 is just 12, so you have that. Now the second row times the first column. So 4 times 1 is 4, plus 5 times 3 is 15. So 4 plus 15 is 19. And then the second row and the second column, so 4 times 0 is 0, plus 5 times 4 is 20. 0 plus 20 is just 20. So that's AB. Now what is BA? Is it going to be the same? well, let's see. So BA is going to be, so you have 1, 0, 3, and 4. And then with that, you're multiplying 2, 3, 4, and 5. So let's see if you get the same answer or not. We're probably not going to get the same answer. So we have 1 times 2 is 2, plus 0 times 4 is 0. So that's just 2. Well, we really don't have the same answer. We can see that entry is different. 11 is different from 2, so that's not going to be the same matrix. Then we do the first row in the second column. So 1 times 3 is 3, plus 0 times 5 is 0. So that's just 3. And then we have 3 times 2 is 6, plus 4 times 4 is 16. 6 plus 16 is 22. And then we have 3 times 3 is 9, plus 5 times 4 is 20. So that's 20 plus 9 is 29. So we can conclude from this right here that AB is not equal to BA. And this is because matrices are different from just regular integers. You can't expect the properties of multiplication to hold with every single thing that we come across. So AB is not equal to BA in this case. Okay, so we've done addition, we've done subtraction, we've done multiplication. Now let's think about division. How would you divide a matrix? Or is that even possible? So before we go to division, I want to introduce an identity matrix. So I is called the identity matrix, and it's just equal to 1, 0, 0, 1. This is if it's like a 2 by 2 matrix. If it's a 3 by 3 matrix, then we have 1, 0, 0, 0, 1, 0, 0, 0, 1. So it's just that the diagonals, these are called the leading diagonals. So the leading diagonal is 1, and everything else is 0. So this is identity matrix. And identity matrix is always a square matrix. So what's a square matrix now? So these are all new terms that you probably didn't know. So what's a square matrix? Well, this is a matrix. Let's say you have A by B other dimensions. Well, A is equal to B. Of course, that makes it square, right? So let's say a 1 by 1 matrix, or a 2 by 2 matrix, or a 3 by 3 matrix, and so on and so forth. So that's a square matrix. Now, back to division. How do you divide a matrix? So what does that even mean? How can you think about dividing the matrix? And the thing is, you don't really divide matrices, but you find inverse of matrices. So we find inverse matrices. And I'm just going to show you how to do it, and we're going to do like 2 examples. But then, because the actual proof of what a determinant is and everything else is very like non-intuitive, you have to go and read into it to understand what it's really doing. So inverse matrices, so what is that? So let's say you have a matrix that's, I'm just going to generalize it, okay? So let's say you have A, B, C, and D. We're just going to work with 2 by 2 matrices because those are very simple to deal with. In the next video, we can do a 3 by 3 matrix. So you have a matrix that's A, B, C, D. A, B, C, and D are just numbers. So an inverse matrix only happens, so an inverse only exists, and now there are 2 conditions. So number 1, it has to be a square matrix. So you can't find inverses of non-square matrices. So it has to be a square matrix. So it can be 2 by 2, 3 by 3, 1 by 1, 5 by 5, whatever. And the second thing is the determinant, I'm going to explain what that is not equal to 0. So what is the determinant of a matrix? It's actually very simple. It's not that difficult. And you will see why it can't be equal to 0. So the determinant, so I'm going to write det, and I'm going to write the matrix as A. Okay, so that A is not equal to 0. So what is determinant of A equal to? The determinant of A is equal to A times D minus B times C. So you do AD minus BC. So you do this diagonal minus this diagonal multiplied together. So that's the determinant. And the reason it can't be 0 is because now, how do you find the inverse? So the A inverse is given by this formula. So you have 1 divided by the determinant of A. And now you can see already, just from this right here, that if this is equal to 0, then you would have 1 divided by 0. So this is not equal to 0, once again. Because if this is 1 divided by 0, anything divided by 0, we know we can't work with that. So that's why this cannot be equal to 0. So 1 divided by determinant A. And then here, you just change the order around of the matrix. So now you have D and A, so you swap those 2 around. And then for B and C, you keep them in the same place, but you add a negative sign in front of them. I know this is a lot of like, why is this happening? And it's difficult to explain why it's happening. Maybe you should go and read on it. Maybe you can do some more searches. Maybe I might make a video explaining why it happens. But for now, let's just learn how to do it and look at some examples, okay? So let's say I gave the matrix A is equal to, what should we do? Let's do 4, 3, 2, and should we do 1? Let's do 1. 4, 3, 2, and 1. So let's say that's our matrix. And we want to find A inverse. So how do we find A inverse? So A inverse is equal to 1 divided by, now we need the determinant of A. So what's the determinant of A? So the determinant of A, I can write that right here, is going to be equal to, well, we said AD minus BC. So we do 4 times 1, so that's 4, minus BC, which is 3 times 2. So 4 minus 6, which is equal to negative 2. So it can be negative, it just can't be 0. So we have 1 divided by negative 2. And then we have to switch the orders around. So we swap 1 and 4 around. So we'd have 1 here and 4 here. And then we change the sign on 3 and 2. So it becomes negative 3 and negative 2. And let's simplify this. So this becomes, so I'm going to bring the negative 1/2 inside. So we'd have negative 1/2. So you just multiply everything by the constant over here. So you have negative 1/2 times all the entries individually. So you have negative 3 times negative 1/2 is just 3/2. And then you have negative 1/2 times negative 2 is just positive 1. Then you have negative 1/2 times 4 is just negative 2. Okay, so that's A inverse. Okay, so how do you check that this is the inverse? How do I know I'm correct? Okay, so the reason this is the inverse is because let's say you did A inverse times A. Let's try it and see what happens. So you're going to multiply A inverse and A together. So you're going to have negative 1/2, 3/2, 1, and negative 2. And you're going to multiply that by original matrix A. So that's 4, 3, 2, and 1. So let's multiply and see what happens. So we end up getting negative 1/2 times 4 is negative 2, plus 3/2 times 2 is just 3. So you get negative 4, or you get negative 2 plus 3, which is positive 1. So you put that there. Then you do negative 1/2 times 3, so that's negative 3/2, plus 3/2 times 1, so that's 3/2. So negative 3/2 plus 3/2 is just 0, so you have 0 right there. And then you have 1 times 4 is 4, minus 4 plus negative 2 times 2, so that's minus 4. So 4 minus 4 is 0. And then here you're going to have 1 times 3 is 3, minus 2 times, plus negative 2 times 1, you could say, and that's 1. And you can see this is the identity matrix that we saw earlier. 1, 0, 0, 1. That's the identity matrix. So the whole idea behind division is you can't divide matrices, but what you can do is you can find the inverse of a matrix, and the inverse of the matrix multiplied by the matrix gives you the identity matrix. And this is very important to remember. And actually, you can change the order around this time. So now you can also do A times A inverse, and that will still give you identity matrix. So let me make that an equal to. That is equal to A times A inverse, which is equal to the identity matrix. So let's see what we've learned so far about matrices. So matrices is just rows and columns of numbers. So you can have 2 by 2 matrices, 2 by 3 matrices. You can have any dimensions you want, right? So these are the dimensions of a matrix, these numbers here. You can only add matrices if both the matrices that you have the same dimensions. You can only multiply matrices if the number of columns of the first matrix matches with the number of rows on the second matrix. And you're going to end up with the resulting matrix having the number of rows from the first matrix and the number of columns from the second matrix, as we saw over here. Now, that's just examples of multiplying matrices. We saw how we did that right there. You multiply the first row by the first column, and then you add the entries, and then you keep on doing that for all the others. And we saw that we can't really divide matrices, but what we can do is we can find the inverse of a matrix, and this is the formula for the inverse of a matrix. And what the inverse of a matrix does is, when you multiply the inverse by the original matrix, you end up getting the identity matrix, which looks like this right here, 1, 0, 0, 1, or just 1 in the diagonal and 0 everywhere else. And honestly, an inverse is dividing, because if I told you 6 times 1 over 6, well, that gives you 1, right? If I told you 5 times 1 over 5, that also gives you 1. So imagine 1 is the same as the identity, 5 is the original thing, and then the inverse is 1 over 5. That is exactly what division is, because when you divide something, let's say I did 5 divided by 5, that is the same as 5 times 1 over 5. So that's 5 times the inverse of 5. Inverse of 5. And you end up getting 1, which you could call the identity. So you can see matrices are doing the exact same thing, but instead of dividing two matrices, we multiply the first matrix by the inverse of the second matrix, which does the exact same thing as dividing two matrices, and you end up getting the identity matrix. So yeah, hope that made sense. And in the next video, let's do some inverse matrices of higher order square matrices. So let's do like a 3 by 3 matrix. What would that look like? What do you think the inverse of a 1 by 1 matrix looks like. And to be honest, I just told you the answer right here. So yeah, hope you liked the video. If you did, please like, share, comment, subscribe, and let me know what else you want to see in future videos.